My name is Mook Srinivasan, Senior Sales Engineer here at Couchbase. I look forward to showing you what we're going to cover in our presentation.
Hi, I'm Ian Maxon. I'm a developer, software engineer on Python UDFs.
In today's session, we'll be covering machine learning meets NoSQL using Python UDFs to help you get more. We're going to be covering why we started this, followed by what we did to show it to you, and then finally, how it works in real life. And then Ian's going to cover the architectural overview and next steps. So let's begin. Reality is people don't do things unless there's a need and a challenge. Things like, how can I do my job without the ETL? How can I hypothesize without the hassle of data movement? And things like, how can I get real-time predictive insights using my Python models that I've spent hours, days, weeks, and months creating? It was these kind of questions that led us down this path to a scenario such as Come Fly Away. They're a worldwide travel site, and they'd like to understand and provide users greater control over their travel plans by letting the travelers choose nearby locations, determining the crowd sentiment of their chosen venue, using all of the incredible machine learning models that our data scientists have been creating. So what we'll be doing today is we're going to show you how to train the models, create the Python library, package and deploy it to the analytics servers, then in analytics, define the UDFs using Python's user-defined functions, and then ultimately derive the insights from all the work that we have shown.
All right, so I'll be showing how Python UDFs work from a user level and some of the technical details therein. So first with the technical motivation, right? So analytics up to this point, right? It had nickel UDFs, but it did not have any sort of external language UDFs, right? So why choose Python as the first foreign language UDF for Couchbase Analytics? So the story behind the story, the major motivation was that the thought was, wouldn't it be so cool if you could deploy some sort of trained machine learning model and run it as part of a query? And so if you have Python, right, Python is, right, it's the lingua franca of machine learning, right? Almost every machine learning library will have some sort of Python interface, right? So if you have Python UDFs, you can go ahead and use a machine learning model as part of a C++ query. And just in general, it's also highly useful for, some of the reasons that it became useful for machine learning is just that it's highly versatile for anything that you might want to implement with a minimum of fuss. So given that, right, how do you put Python into Nickel for Analytics in C++, right? So the general idea was to make sure that basically you could take the user's code, right, and don't force them to make it fit to any particular model, any type of particular programming model. Don't make them import any sort of library or type model or anything like that. Just take their code, take it as it is, right, and be able to run it as part of a query. And so to do that, right, we can take the dependencies of the user's code, right, and group that into libraries, right? So it's like a hermetically sealed container of all of the dependencies of the user code. And then basically allow the user to define the binding between that code and Nickel for Analytics. So that way you can avoid namespace conflicts inside for functions that already exist inside of Nickel for Analytics, and allow the user to reuse the code by defining, you can define the function multiple times. So given that, let's get down to the brass tacks of what this actually looks like. So let's say that I had a module, right, named myfunctions.py, and inside of that, I just have this function, right, round trip, and it takes variable arguments and it returns those arguments. So in order to package this, like I was talking about, to seal it up, to be able to send to analytics, right, we use this tool called Shiv. And so basically it takes the code, right, in the site packages argument, right? So we're just going to say it's in the current working directory, and it takes the list of dependencies, right? So we're going to say here it uses NumPy as a dependency, even though obviously it doesn't, just for illustrative purposes. And then to upload it, we have a REST API that takes this package that's been created now and sprays it across the cluster, all of the nodes in the cluster, and make sure it's all there, so it'll be run as any part of query, as a part of a query, right? So basically, we'll go ahead, we'll post it to this API endpoint, this analytics/library at default, which is the scope, and then mylib, which is going to be the name of the library, right? So this will become a language artifact. And then these parameters here, it's a multi-part form data request, and it takes a type parameter, and that's going to be Python because that's the only one supported at this point. And then the data field will actually be the binary content of the library. And so once that's uploaded, you can go ahead and use this create function, analytics function DDL, right? And we're going to call the function round trip because we can call it that. We don't have to call it that. We can call it whatever we want, right? Just because it's named round trip here doesn't mean that it has to be round trip here, right? And we're going to say it takes one argument, even though it could take more args, right? And we're going to define it as my functions, right? Which is the module. So the first part of this is the module. And then the second part is it's either a method.class or just a function name. And so in this one, right, it's a top level function. So we'll just say round trip. And then we're going to say it's at mylib, right? So we say it's at the library. So the function is at the library. And then after you define the function, you can just use it like any other scalar NCL for analytics function, right? There's nothing special about it. You don't have to worry about it. You can use it as part of a query and it should just work. So we'll go ahead and demo this. But first, to give a little bit of a preface of the data and the setup. So we're going to use the integrated travel sample data that's part of Couchbase. We're going to use the hotel inventory reviews. And that's basically that data set contains, there's basically there's hotels, and then inside of them, there's a field that has the reviews of those hotels. And then there's another data set that's about airport locations. And so we'll do a join between those two. And then for the UDFs, there'll be some really simple ones. But two of the ones that are a little bit slightly more complicated, one of them is going to be UDF that calls this machine learning model called Roberta. And so this is it does a lot of things, but we're just going to use it for sentiment analysis here. And then there's going to be another one that'll be kind of for illustrative purposes. That's just a logistic regression in scikit-learn that was trained using airline reviews. And so with that, let's go to the demo. So I have the Couchbase instance set up here, and I have a shell on my on the machine that it's on. So first, let's go ahead and take a look at what these UDFs actually look like in terms of like what we're going to actually upload. So I've unzipped the PYZ file here that gets uploaded. So let's take a look inside. So there's a variety of things in here, right? A lot of the dependencies, but one of them, but the UDFs also exist in here, right? So let's take a look at sentiment simple, right? Which is one of the UDFs that we'll be showing. So this UDF, right? It's a class, right? And inside of the constructor, right? We open a file here called good.txt, and then we just read the lines. And we put that into this member variable, right, whitelist, right? And so the reason for doing this, right, is because basically this class will exist for the lifetime of the query. So we can read this file once and then reuse whatever we extract from it, we can use inside of this sentiment function, right, which will be called for every tuple that flows through the query, right? So it'll be called one at a time. And so in this, right, we're pretty much saying, okay, so it gets given a string, right? And we say, okay, so if that word is in this list of words that we loaded, right, return great. And if it isn't, then return right? And so we can look in this file, good.txt, right, which is part of the library, right? And it says spam, eggs, or ham, right? So if it's spam, eggs, or ham, it'll be good, or it'll be great, right? Otherwise, it's So, okay. With that said, let's go ahead and start defining the functions in analytics. Okay, now that we've looked at the function, we can go ahead and upload it. right? So this is basically the same as the function that I was showing in the condensed slide, right? Except here we're going to upload it to the travel sample scope, and the function is going to be named simple, right? So that after this is uploaded, right, we'll be able to use this DDL here that's in the query editor, right, to expose it as a NCL for analytics function, right? So, right, so this function round trip, right, this exists. I didn't show it, like it exists in this my functions module here, right? And it's the one that was on the slide, but except that it's a method inside of a class rather than a top level function, but otherwise it's the same. Then we define the simple sentiment function that we were just showing. And then we define this get scikit sentiment function, which basically it goes ahead and it pipes the text to the logistic regression I was talking about earlier. And then it'll define one more function. So this is this batched Roberta sentiment, right? That I was talking that we were going to use Roberta, be able to pipe text into Roberta to classify it as positive or negative, right? This is at a different library. We already uploaded it previously because it takes a little bit longer, but we'll just define it here. And then finally, we're going to create one more function. So this is distance in miles. So this one is just it's a simple Euclidean distance between 2 points. You basically give it a object that contains lat and long, and it'll just do the simple Euclidean distance between those 2 points. So it's not, there's no real geospatial distance here. It's just straight line. And so with that, we can show basically the execution of these functions, right? So previously, right, we showed the round trip function on the slide. We'll go ahead and run that. And so we give it spam, and it gives you back spam, right? It gives you an array because it's giving you all the arguments. Now let's try the simple sentiment function that we were talking about earlier, right? So this one, we were saying, okay, if it's, let's take a look at the good.txt. So basically, if it's spam, eggs, or ham, it'll return great. Otherwise, it returns bad. So we run it, and it does exactly what we would expect. Then, for the last few examples here, I'll show, we'll use the scikit function. So this one is a little bit more advanced, right? Instead of just having a list of words, right? We can go ahead and it'll use the logistic regression to kind of classify, oh, okay, is this good or great? But we'll just use this one for demonstration purposes because sometimes this doesn't work so well because, for example, it just tries to look for the occurrence of words that are, that are on one side of the regression or not. So, for example, this, right, it doesn't handle things like negation, right? Like here, it would think that both of them are negative, right? So later on, we'll basically use Roberta, which doesn't exhibit some of these problems. So yeah, I think with that, I'll hand it off to Mook, and he can show you some more advanced queries that relate to the come fly away example.
Thank you, Ian. I'm going to start sharing my screen. What I've done is to ensure that you can actually see what I'm sharing. I have zoomed in on my picture, and what you may or may not experience is some of the picture running off the side. So to start, let me show you what I've written here using the formulas that Ian has shown earlier, which is I'm going to just identify using the same data set he was using, which is our travel inventory hotel information, which I've set up over here. And in that, I'm going to grab some hotels and their reviews. So remember, the story was we want to give users the ability to look at places to stay based off of the crowd sentiment in specific areas. So to set this up, first, let me start with the Laurel Inn. That's where I stayed last year. I'm going to run a straightforward query that says, hey, I stayed at this location. What are some of the reviews? So you'll see some things like, hey, I was over at Mother's Day on business. It's a great choice, so nice and positive. You see another one, beware the bed bugs in this hotel. Definitely don't want to stay at a hotel. So, or a hotel with bed bugs. So let me move on to one that actually gives me a little bit more details, which are last time, not only do I not want to stay at somewhere with bed bugs, I also don't want to live in a cab going between places. So let me restrict the area by where I'm going to look for hotels. And I'm going to leverage what Ian brought in his section, which was the function called dist.me, distance in miles between two geographic points. And I want to make sure it is closer than 11 miles. And since I'm staying in San Francisco, I want to make sure that I'm reviewing hotels that are near San Francisco as opposed to something, say, in New York. That would only diffuse and reduce the value of the information. So what have I done? I have said I want to have it in a specific geographic location within a specific geographic scope. And then my choices, meaning I don't want it to have bed bugs. So let me go ahead and execute that. It's using the information that was collected from Ian's work earlier and my characteristics, which are those that I just outlined. And it's found, hey, there are these hotels that meet your criteria. So showing you the result is one thing, but why is this valuable is the other, which is now you're starting to build out valuable features that can be imported into your applications and provide great value to your customers. So now that I have found these pieces of information, I am going to take it one step further and give the opportunity of using the get batched Roberta sentiment, which is what he had imported, which gives you greater understanding of the positives and the negative reviews. And I'm going to keep my prior use or prior requirement of I don't want bed bugs in the specific scope near the specific hotel. So let me go ahead and run that. And as you see, as it's running, it's going to start looking at all those reviews, grouping them into positive and negative against the hotels that we identified, and ensure that all the negatives are all the positives, and then show you, hey, there were more positives than negatives in certain hotels. In the scenario of Inn on Castro, there was one negative hotel or one negative review, and that's it. But then you have other hotels like the Parker House or Twin Peaks that have overwhelmingly positive reviews. What this gives you is the ability to say, hey, these are hotels with a certain minimum, I didn't do that in this scenario, but a certain minimum of reviews, and their frequency of positive reviews outweighs their negatives. Again, why do you do this? Because it gives you the flexibility and ability to add new features without having to do a whole bunch of other overhead, while leveraging all the work that your data scientists have done. So you saw what we both demonstrated of how to import it, why it's of value, and how it runs so that you can, in fact, use it in a real world scenario. So what are the benefits? You're able to get the Python machine learning models closer to where the operational analytics resides, meaning take the compute to the data, as opposed to moving massive amounts of data over the wire, creating data redundancy and increasing your storage costs. You're now able to bring your compute to the storage, to the location of your data, one. Two, since analytics is able to reach out to third-party storage buckets, you've increased and introduced a far greater and more powerful analytics tool without having to move data in different locations and extend your analytics reach. And then since it is where the data lives and there is no data duplication, you're able to get to insights far faster than if you have to do the necessary output, movement, ETL, and then finally run those analytics. So let's look at what's on our roadmap, as well as what was the architecture behind this, to show you what you just saw. Go ahead, Ian.
So the demo, right? So we had Python code, and it was run in parallel across the cluster. So how was it accomplished? And then we'll talk a little bit about what's next for the Python UDFs. So kind of in a nutshell, right? So analytics is a MPP style system. And so there are many nodes operating in parallel, and they have many partitions of data. And so when the query gets run, it gets split into pieces that each node will run, and then it'll all be put back together to present the entire result of the query. So internally, the name of the service that runs this is called the node controller, right? So there are n node controllers that exist in the analytics cluster, right? And so for those node controllers, when you run a Python UDF, right, basically the function call inside of the operator that runs that gets the function, right, it'll go ahead and it'll fork off a Python process, right, and it'll wrap the function that you define in the VDL in this entry point.py wrapper, right? And so this wrapper handles the communication between the analytics process and calling Python and then returning the result back so that analytics can integrate it as part of the query, right? So it takes the input of the query through standard in, and then it goes ahead and it gives it back on a localhost port. And so, but this is done for it, like, for example, if we have one interpreter per library, per query, right? And so part of the reason that this localhost port is done is because this is shared between those interpreters. So you don't have a giant explosion of ports being used, right? You're not going to have this port starvation. If you have a query that uses, multiple UDFs in multiple libraries, right, it should all be relatively constrained. And so, yeah, so basically the thing to take away, right, is that when we showed that code, right, that's basically, okay, it's not inherently parallel, right, but we wrote it in a way such that it doesn't have, it's functional roughly, right? It doesn't have it doesn't write things, right? And so it was put onto the cluster, right, deployed in parallel, and then as the query, it's automatically run at the level of parallelism as the query, right, without the developer having to really worry so much about it. So given that, so this is a developer preview feature. So there are things planned to bring it to general availability. So talk a little bit about those. So one of them right now is that, so this right now, the way that these, I was saying that it runs an interpreter, right, for each in the query, right? So that interpreter is just run as the daemon process. It's run as the same user as the Couchbase process itself, right? So this is dangerous for basically, right, that code, right, has an unnecessarily high level of privilege, right? Usually a UDF code, it shouldn't need to be at that. There's very little reason that you would need that, right? So in general, it should be at a lower level of privilege, right? It should only be able to read the things that are necessary. So that's, in other systems, sometimes that's known as fenced execution. So that's one of the main things that's on the roadmap. Another is that, we were showing Shiv and curl and all these things, right? There will be a front end that kind of makes these details a little bit nicer, right? Instead of having to use these, having to use the API, the bare API. You'll be able to still if you would like to, right? But just as a convenience, maybe have a front end for it. And then, yeah, right now, as I said, right, these interpreters are started and torn down for every query, right? And that's not strictly necessary. There may be some cases where you'd want to do that, but it shouldn't be strictly necessary. And so this is okay when you have queries that, like we were showing, that take many seconds. But if you have a query that's very short, the interpreter start and stop can be a significant portion of that. So we'll go ahead and reuse those interpreters where possible. And there's a litany of other performance improvements that are kind of low-hanging fruit, and those will be right. Those can be implemented. So that's all that we had to show for Python UDFs in Couchbase Analytics. Thank you for joining. Hope you enjoyed it. And if you have any questions, please feel free to reach out to either me or Mook at the emails listed in the contact slide. We'd be happy to answer any questions that you have about this feature or other features in general.